so first of all, on this one, we need to change that radical to an exponent, and then we've got a double chain rule. For n, this is going to be a chain rule again. You hit the natural log first, so that's going to be 1 over. And then the derivative of the inside is just 6, if you wanted to simplify that. And then here, in this question, you're looking at all your functions, and the 3x squared and the ln 5x are two different functions, and they're multiplied together. So this one has a product rule. And when you look at each of your functions separately, well, if I keep the first one the same, the derivative of the second one has a chain rule because there's a 5x inside of natural log. So we first do the derivative of natural log, which is 1 over, so it'll be 1 over 5x. Then the derivative of the inside is 5, so we multiply by 5. Then you keep the second one the same, and the derivative of 3x squared is just 6x. And you can simplify that. So in this question, looking at the original question, I see dividing, so I'm starting to think, oh, I might use my quotient rule. And in my quotient rule, you keep the bottom one the same. The derivative of the top, well, the only thing you have to take the derivative on the top is the natural log of x. There's a negative in front of it, that negative stays. So you got negative 1 over x. Then you keep the top one the same, the derivative of the bottom is easy over the whole thing on the bottom squared. Again, if you wanted to simplify this, you could. And further simplifying it, can you see that in both terms, there's one term here and one term there, that they both have an x to the 4? So if I factored out that x to the 4, I'd be left with negative 1 minus 5 times 2 minus ln x. And the nice thing about simplifying and taking out that x to the 4 is this will cancel out and leave only 6 there. So we can write this all over x to the 6th. In a lot of textbooks, especially when you get to university, they will always simplify as much as they can in their answer book. So you do the derivative, then you look in the answer book and you're like, it's not the same. Well, it's basically like an identity problem for you. You do the first steps in your derivative, and then you want to try to see if you can match the answer that's in the back of your book to see if you can get them the same. And that's where a lot of algebra and factoring skills come into play. So here we have two functions. Change the square root with brackets to the power of a half. Keep the first one the same. Derivative of the second one. It has a chain rule in it. Then keep the second one the same. Derivative of the first one. And if you simplify that, so what I did with the simplifying this 7 minus 3x to the negative a half, well, negative half moves it to the bottom of a fraction, and a half makes it a square root. So that's how that negative a half ended up on the bottom of the square root there. And do we have one more? Ooh, exponent of 17. So again, we're going to have our product rule and chain rule. Keep the first one the same. Derivative of the second one, so the 17 comes out in front, subtract 1 from the exponent, but when you look inside, you can take the derivative of that and get 2. Plus, keep the second one the same. Again, we got a product, power rule there, bring the 6 out in front, subtract 1 from the exponent. And then look inside the function, and again, you can do the derivative of the inside. So we multiply by 2x.